All right, today we're going to do resonance structures. We're going to do coordinate covalent bonds. And if we have time, we're going to do expanded octets. All right. So yesterday, I asked you at the end of class, what do you call that layer in the earth that helps protect us from ultraviolet radiation? You said it was ozone. Well, the chemical formula for ozone is O3. And so as we were winding down yesterday, I asked you to try to come up with a chemical structure, a Lewis structure, that shows all three oxygens bonded to each other so that each one has 8 valence electrons. No more, no less. Did anybody try to do that? Nicole, you think you did? Okay, why don't you come up to the whiteboard? I know people at home can't see you, but I will draw it on the screen. So why don't you come up to the front and see if you've got it. So if you're watching at home, you can just kind of fast forward through this part while she's doing it, and we'll put it on the screen. It's a worthy effort, but if you're watching at home, here's what she has. Yeah. Okay, so let's count these up. 2, 4, 6, 8. Okay. Next one. 2, 4, 6, 8. Next one. 2, 4, 6, 8. So in chemistry, you can't form the structures like this because the repulsion forces are too strong. So they can't form things like a triangle. You can do this with carbon, but not with oxygen. And so that was a good guess, but here's what it actually looks like. So here we go. You start off with, there will be 3 oxygens in a row. So let's start off with our first one. 1, 2, 3, 4, 5, 6. Okay? Here's our red one. 1, 2, 3, 4, 5, 6. Here's our green one. 1, 2, 3, 4, 5, 6. All right, here's how this goes, guys. This is going to be kind of crazy. This electron over here is going to move over here. And it's going to form a bond. This electron over here is going to come over here, form a bond. This electron over here, if I can move it, it's going to come over here, form a bond. Put that there. Actually, hold on. Okay. Now, this is going to be multiple ideas at once. And I know that this is going to be blowing your mind a little bit. That's a bond. That's a bond. Actually, no. I got that flip-flop. Let's try that again. Sorry. Okay. There we go. Okay. So that one has 6. There we go. How many electrons does the green one have right here?
8.
Has 8. Okay. Two, 4, 6, 8. 2, 4, 6, 8. This electron is going to come over here. If I can move it. Coming right here. How many electrons does the red one have now? 8. We have 2, 4, 6, 7. We have 7 there. 1, 2, 3. 1, 2, 3, 4, 5, 6. I left one out. All right. So the black oxygen originally had 1, 2, 3, 4, 5, 6. Here's what happened. And this can be really confusing. This is going to be a shock to your system. I will be patient with you. Don't worry about that. This guy right here is called a coordinate covalent bond. The coordinate part means I've got you covered. Max and I go out to lunch. Lunch costs $5. Normally, I will pay for my lunch. He will pay for his lunch. We're going to have a nice lunch. Max forgot his wallet. I'll be like, Max, I got you. Pay me back later. I will cover your lunch. In this case, the red oxygen does not have any more electrons to give. And so the black oxygen is going to provide both electrons necessary to make the bond. That is why this is called a coordinate covalent bond. Covalent means that they share. Coordinate covalent means rather than a one-to-one share, one of the atoms is going to provide both electrons to form the bond. And so the way this looks when it's all done is like this. That is ozone. Everything is accounted for. 8 electrons. I expected no one to get that. Yes, Kevin?
But doesn't the middle oxygen not have 8?
And that's going to be called an expanded octet. I know there's a lot. I'm violating every rule that I've told you about. There are these circumstances that occur in nature where it turns out that you can have more than 8 and you can actually be stable. There's something called sulfuric support. I still have it up here. How many bonds do you see bonded to this yellow guy?
6.
How many electrons are there in one bond? 2. 2 times 6 is 12. So technically, this sulfur, which is yellow, has 12 electrons in its valence shell. It should have 8. This is one of those exceptions to the rule, and there will always be an exception to the rule when it comes to science. I do not want you guys to glorify the exception to the rule. 1 out of 99 is not always, but it does happen. Yes, Nicole?
So the bond, the double bond between the 2 oxygen ones, the right and top one,
Mm-hmm.
how does that,
The double bond on the right?
yeah, there.
Okay, what about it?
Oh, there, okay, because so it should it be circled with the 2 electrons there too?
Yeah,
Um,
yeah, I made a little
Is that
mistake
like
there.
both
Sure.
ways?
So let's fix that.
Okay.
There you go. Okay. Sorry about that. Sometimes I go fast. I leave out those little tiny details, and the tiny details are the big ones that matter. So, how many valence electrons does this oxygen on the left have? 8. How about the one on the right? 8. How about the central oxygen? 10. 2, 4, 6, 8, 10. Yes, Arshawn.
How is it gaining any electrons from the bond it gives those electrons to? Like,
Because those electrons belong to the original atom that donated them. If you look here, 1, 2, 3, 4, 5, 6, 7. Wait, 2, 4, 6, 8.
yeah, like,
Oh, I see what you're saying. Okay, I see what you're saying.
'cause it could
You're
give-
right. You're right.
give
I'm.
electrons to the other one, it's not
You're right.
gaining.
I'm bad.
Okay.
Worse than bad. I haven't gotten to expanded octets yet, but those do exist. So that's it. Does that make more sense for now? A little more sense? A little more.
But
It's still 8.
it's still gaining 2 from the one that
It-
it still has none. Okay.
So this bond here that I have highlighted in green, this is the coordinate covalent bond. In a coordinate covalent bond, rather than both atoms provide an electron, one atom provides both. I accidentally just drew an extra pair of unshared electrons. That was my bad. Yes, Arshawn.
So the middle atom is gaining nothing from the atom from the bond on the left,
That's right.
but the lower left is getting 2.
Yes.
anyway.
And this is able to form the whole compound. This is just your standard traditional double covalent bond. Now, not only is this an example of a coordinate covalent bond, this is an example of a resonance structure. Is there another way you could draw this molecule and still be right? How? What do you mean flip it? Yes. So if any of you drew ozone like this, I would give you credit. The other way to draw it would be like this. As Francis said, just flip it. This is also correct. So a resonance structure is simply more than one way to skin a cat. A resonance structure means that a molecule has multiple correct Lewis structures. So it's kind of a bumpy road. We're going to try to smooth it out. Just relax. And I'm going to give you guys another one. What do you call that gas that people die from when they are running their generators inside their own home? Carbon monoxide. It happens every year. It's during a hurricane or when it's really, really cold out and people don't have a working heater. They try to power with the generator. They bring the generator in the house. People die. Yes.
Can't that also happen if you leave your car on?
Yes, I'm glad you said that too. A couple years ago, I taught this, and I said, you know, when you close the garage door and you have your car running, your car is emitting exhaust just like a generator is. And so I had a student a few years ago. She said when she got home, she was in the car and she closed the garage door and she was sitting here texting on her phone. And her dad came around and I was like, turn off the car. She's like, ah. It's like, you're going to kill yourself because the garage door is shut and your garage is filling up with exhaust. Exhaust is carbon monoxide. It is an odorless gas. You don't know it's coming. You obviously smell the fumes of your car. There's a lot of different pollutants in there. And so if she had stayed in there, she probably would have just done this. Dead. You don't even know it. So when you guys start driving, you're getting pretty close. You're sophomore, so you're going to be turning 16 soon. Don't leave your garage door open. excuse me, you're closed. Don't leave your garage door closed when your car is running. I park my car in the garage. First thing I do is I open the door first before I turn my car on. Just one of those basic things. So carbon monoxide. Let's see if you can do this. Carbon monoxide is 1 carbon, 1 oxygen. I want to see if you can get these to bond together, and I will give you a hint. There will be a coordinate covalent bond. So carbon has 4 valence electrons and oxygen has 6. I need you to try to work it out to where both of them gets 8. There will be a coordinate covalent bond involved here somewhere. Yes.
And then if there's like a double bond, in a double bond, can one of the 2 bonds be covalent?
Yes. One can be covalent, one can be a coordinate covalent. If you think you've got it, come up to the board and let's see what you got. Hey, can I give you, let me listen to this real quick. I want you guys to stop for a second. I have a friend of mine who's a manager for an insurance company. He's a assistant manager kind of, and he is responsible for hiring people. And one of his questions is, why are manholes circular? You know, the holes in a sewer. And the reason he asked that question is if he will have an applicant actually answer it. If an applicant says, I don't know, you're not getting the job because they didn't even bother trying. If he gives them the craziest, weirdest, goofiest answer, he will probably hire them, or at least he's more inclined to hire them because they tried. That's how I want you to approach things in this class. People do not get jobs because they don't even bother trying. I want you guys to at least try. Nicole tried, and I truly appreciate that. So I want you guys to try. Michael Jordan said, I would rather try and fail than not try at all. So Arshawn coming up. And by the way, the reason they're circular is because you don't have to fit it properly. Just a circle, so it just fits. You don't have to be like a square and line it up. It just fits. Hey, do us a favor, Arshawn. Use one color for carbon, one color for oxygen, so we can definitely see the difference. For those of you watching at home, I'm going to draw for you what Arshawn draws, and we'll see if he's correct or not. So he's doing it right now. You have 8 there. So you have 2 on one side of the carbon and 4 on the facing side of the oxygen.
Yeah.
The electrons that face each other have to be equal amount.
What do you mean? Wait, say that.
You have 2 on the right side of the carbon. You have 4 on the left side of the oxygen. So you have 2 facing 4.
Oh, couldn't one of them be coordinate?
Yeah, but you have to throw a. I get where you take one of those electrons you have. You see the 4 together?
Yeah.
Take one of them and put them over on the carbon side. Just one.
Okay. Like still from the oxygen?
Mm-hmm. And
Okay.
you erase them. There you go.
And then so this gets
8.
yeah, right?
Yes. 8. Okay. So if you're having trouble seeing that, whether you're at home or watching this class, here's what he did. Guys, pay attention because he's right. Here's what he did. He put his carbon. How many valence electrons does carbon have? 1, 2, 3, 4. Okay. How many valence electrons does oxygen have? 6. Here's what he did. 1, 2, 3, 4, 5, 6. Which one is the coordinate covalent bond? The top one, the middle one, or the bottom one? The bottom one. The definition of a coordinate covalent bond is where one of the atoms provides both electrons for the bond. So that is carbon monoxide. It looks like this. That's a triple bond. What shape is that? What molecular shape? That's linear, it's straight line, 180 degrees. And that bottom bond right here, that's the coordinate bond, the bottom one. Yes, Nicole.
So would that, so that's like a triple bond, but would it have like one pi bond, one sigma bond?
It would have
coordinate bond?
it would have 1 pi bond, 2 sigma bonds.
So what's the coordinate bond?
The what?
So what's the coordinate bond?
That's going to be, it could either be part of the, let's see, you got the sigma bond here. So that's going to be 1, 2, that's going to be the pi.
So the coordinate it is a type of sigma bond.
Yeah.
I thought a triple has 2 pi's and 1 sigma.
I thought it was 2 sigmas and 1 pi.
Oh, am I wrong?
We'll look that up. All right. So 2 pi's, 1 sigma. So that highlighted one would be sigma then, and the other 2 would be pi's. And they're going to overlap like that.
Coordinate bonds can be either sigma or pi. It's just a different type of bond.
Yeah. It's just going to behave like a regular triple bond. You just happen to know that that third bond is going to be 2 electrons rather than 1 from each.
So it always looks normal on.
Yeah, it looks normal. You just have to know that there's not going to be an indicator like I highlighted for you that, oh, that's a coordinate covalent bond. It's going to look like any other triple bond. You would just have to know that one of those bonds was formed by a coordinate covalent.
That's like the valence electrons of each atom.
Yes. Okay, so now I'm going to give you guys an extra one to try. I want to see if you can do this. So here we go. This will be the last one we try. Let's, yeah, this will be the last one we try. Nitrate. Now, here's how I want you to do this. Please listen. You see that negative symbol? Does that mean 1 electron was added or 1 electron was taken away? So hold that in your back pocket. When you're doing your bonding, know that if, oh man, I got 2 that have 8 and 1 that has 7. Wait a minute. You got that 1 electron in your back pocket. So see if you can get this to come together. So nitrogen has 5 valence and oxygen has 6, and you have 3 oxygens. So let's see what you've got up your sleeve.
So should we also have 8 so you can just add another electron?
Yes. There's going to be no expanded octets here yet. Now, let me help you a little. Because there's 1 nitrogen and 3 oxygens, which atom is going to be in the middle of this ion? The nitrogen is going to be in the middle. There will be a coordinate covalent bond somewhere. There will be a coordinate covalent bond? Do another minute. All right, you ready? So I'm using 4 different colors so you guys can keep track. Here we go. So nitrogen has 5 valence electrons. First off, I'm going to have a double bond up here. Oxygen has 6 valence electrons. So if I form a double bond there, how many valence electrons will that red oxygen have? 8. So that one checks out. But remember, you got to be 4 for 4. You can't be 3 for 4 or 2 for 4. They all have to have 8. Let's go over here. Nitrogen has 1 valence electron there. Let's have oxygen have 1, 2, 3, 4, 5, 6. How many does it have there? Oh no. But what do I have in my back pocket? I have that extra one, don't I? I'm going to put it in right there. You have that 1 electron that you have as a backup. So have I used a coordinate bond yet? I'm about to. And then I have this one. 1, 2, 3, 4, 5, 6. How many bonds does that or how many electrons does that oxygen have now? 8. And then we do the nitrogen. 1, 2, 3, 4, 5, 6, 7, 8.
Oh, the nitrogen gave.
Hmm?
The nitrogen gave enough electrons.
No, the oxygen did. That purple one right here.
No, in the coordinate, the nitrogen.
The nitrogen gave 2. Yes. So the coordinate bond is right here. So if you put the final Lewis dot structure for this, it would look like this. Okay. Now, this is one resonance structure. There's 2 others. What would they look like? Yeah?
Change the place where the double bond is.
Yep. Could there be another resonance structure? Yeah. Those are the 3 resonance structures for this particular ion. Yes?
So when you're drawing it, it doesn't really matter where the coordinate covalent bond is. You just have to know why it's there.
Yes. Yeah.
So are those like what isomers are, or is that something?
Yep. Now, also, because these are ions, guys, you have to put them in brackets. And you have to write the charge outside the brackets. So what was the charge of this ion?
-1.
So you just put the -1 symbol outside. You have to do that with all ions. You want to try one more on your own? You look like you're having a lot of fun, Trey. You look like you're having a lot of fun.
This is hard.
It is hard. Let's try one more. Practice is what makes the dream work. Here we go. Teamwork or what? I don't know. All right, try this. NH4 with a positive 1 charge. Ammonium. Ammonium is missing a valence electron. Keep that in mind.
Is there any coordinate?
Yes. When it has a positive 1 charge, does that mean an electron was added or an electron was taken away? Yeah. How many valence electrons does nitrogen have? 5. So I gave you the geometry there. Let's see if you can put it together. Keep in mind that 1 electron will be missing.
Does that mean there should be 7?
1 of the hydrogens will have none. So there will be a coordinate bond. Yeah. You could do a coordinate bond, or yeah, you're gonna need a coordinate bond, or you could have the nitrogen missing one.
Yeah.
It'll work either way.
Yeah.
There's more than one way to do it. If you make it work, you make it work. But I'm telling you, that's the geometry of it. It's gonna be tetrahedral. So I want you all to check out what I just did. If you did this, that is correct. Now you might be saying, well, I thought nitrogen had 5 valence. You're right. But what's that little plus sign mean?
Take one out.
You took 1 out. Now that could work. You could also do this. You ready? 1, 2, 3, 4, 5. You take one of the electrons from hydrogen. So there could be a coordinate bond between the nitrogen and one of the hydrogens. And it would still work. So if you included a coordinate bond, like I did here, this is the coordinate covalent bond. You're not wrong. Yeah.
So in the first one, where you took one from nitrogen, there was no coordinate, right? And so does this mean there's 5 resonance structures for this?
No, because a resonance structure would be like up here. You put the double bond in a different location.
But could it
You don't have to consider a coordinate covalent bond as a qualifier to make multiple.
Oh, it's not.
No, it's not. No, there's no resonance structures for this. There's only one. Because the coordinate covalent bond does not mean it has a resonance structure. Okay. I have one more for you, and it is a coordinate covalent bond. I'm going to do this one with you, so let's go ahead and put it together. BH3 plus NH3 is going to yield BH3 NH3. What element is B? Boron. Okay. So BH3 looks like this. We got problems. How many valence electrons does boron have? It's in group 13. It has 3. How many valence electrons does it have right now after we've made these bonds? It has 6. This is called a suboctet. A suboctet infers an element is stable with less than 8 valence electrons. However, we are going to get it to go up to an octet. Here's ammonia. Do you see where the coordinate covalent bond is going to be formed? Where?
The nitrogen's gonna give one to the boron.
It's going to go like this, everyone. Right there. And so it's going to form a bond to look like this. This right here, that is the coordinate covalent bond. You will, on your test, you're not going to be asked to put together coordinate covalent bonds. You're going to be asked to identify where it could be. So the only thing that you really need to know is, how can I get both elements to get 8 valence electrons? And sometimes, if there's more electrons in one of the atoms, it's going to provide both of those electrons to make the bond. Okay, what we're going to do tomorrow is an expanded octet, where you have an element like this. Sulfur has 6 valence. We're going to get up to 12.